Hey guys, so I'm trying something a little different. I actually don't know what this looks like. I'm going to post it no matter what, but I may have to redo it. We're going to go over solving a simple series circuit. Now so far I have given you the rules for series circuits and the two equations. Twinkle twinkle little star, voltage equals I times R, splishy splashy in the C, power equals I times V. So normally this would be a word problem and you would have to draw the circuit, but just for our first one, I'm going to do it this way where I have the circuit already set up, and then I'm going to tell you the values that I know. Now, the goal is going to be to solve everything there is about the circuit. So here I have drawn the circuit, and I have that lit as a resistor. I'm going to call that a bulb or a lamp. So I have resistor 1, I have resistor 2, and I have bulb number 1, and I have a power source or a battery. Now, I'm going to put the rules that we know here for series circuit. We know this is a series circuit because there's only one path for electricity to go through. So my rules for the circuits, I may be off camera, I don't know. My rules were V total equals V1 plus V2 plus V3, etc. No matter how many things we have, we add them all up. My current rule was I total equals I1 equals I2 equals I3. That means the current that goes through everything on here. The current through that and through that and through that are the same. The voltage rule means whatever the battery is, however much potential difference that battery has, some push goes through R1, some push goes through R2, some push goes through that one. And then the resistance rule made sense. Remember, resistance slows down my current. Resistance, and it was called equivalent, is R1 plus R2 plus R3. So I'm going to keep those rules over there. And now I'm also going to remind you that we have only two equations. The equations we have, voltage equals I times R, power equals I times V. So those are my two equations. Now, with this information, we can solve everything there is about the circuit. Now, my question, you might need to listen to this more than once. I'm going to put it into a form, an organizer that we've never seen before. My question is, here we go, is I have a 15-volt battery, or a battery with a 15-volt potential difference, that is pushing an unknown amount of current in the circuit. I know the voltage that goes through the light bulb is 5.53 volts. I know the power of the light bulb. Power is kind of like brightness. The power of the light bulb is 4.37 ohms. And I know the resistance of that resistor number 2, to be 9 ohms. So what I want to know is I want to know everything about the circuit. So I want to know how much current is going through there, there, and there. I want to know the potential difference of R1 of the bulb and R2. I want to know the power of R1 of the bulb and R2. I want to know everything. So to do that, we make a VIRP chart. A VIRP chart? Mr. Rose, what's a VIRP chart? Well, a VIRP chart is exactly what it sounds like. I have a V, an I, an R, and a P. VIRP. Voltage, current, resistance, and power. And now I look at my circuit. Now I want to know how many circuit elements. These things are elements. I have 1, 2, 3 elements. I have resistor 1. I have a bulb. And I have resistor 2. Now I also have a battery. Now the battery is what I call the total. You can call it a total. You can call it a battery. I've always called it a total. And now I'm going to go and put those things in that I just said in my question. I said that I have a 15-volt power supply. So I go to my V, total 15 volts. I know that. I then said I have a potential difference going through the bulb of 5.53 volts. And that's all I know there. I didn't know any of the currents. I did know that the power, the light bulb brightness, had a power of 4.37 watts. And I did know the resistance of R number 2 was 9 ohms. So now you can look at this board, and I'm going to solve 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different things just with these 3 rules and these 2 equations. And I kind of like these because it's kind of like a puzzle. Like, what can I solve next? That's why these are kind of fun. I just got to move some stuff out of my way. So, doesn't matter where I start. I first start with my rules. Like, can I figure anything out? For example, if I know one current, I know them all. So really the key is this. Well, I can't do anything there. The voltages all add, but those can be any number to add to 15. So I need to know some more information. So my rules don't help me, so I go to my equations. Can I do V equals I times R on that top line? Definitely not. I got a V. No, I can't do that one. V equals I times R, I can't do that one. V equals I times R, I also can't do that one. So there's nothing I can do there. So now I'm going to look for the power equation. Can I do any power equals I times V? Power, I times, no. Oh, wait a second. Power equals I times V. So I can do that. So the very first thing I'm going to do is right in here. I'm going to put a number 1, and I'll put a number 1 up here. Now, these change per different questions, but the very first thing I could do, power equals I times V. And I'm doing that for the bulb. So I'm just going to put a little B there so I know what it is. And now I have 5.53 equals, I'm looking for I, times, power equals, that's backwards. Sorry, I knew I messed that up. My power was 4.37. Equals I times 5.53. So you can see I divide both sides. That goes away. Now my current at the light bulb is, got to grab a calculator, 4.37 divided by 5.53 is 0.7902 blah 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 0.79. So that is 0.79 amps. So I go here, 0.79 amps. So I solved something. Now I see what can I do next. I'm going to go back to my rules. Wait a second. If I know one current, I know all the currents, which means I can fill this in 0.79 amps, 0.79 amps, 0.79 amps. And now look at that. My puzzle is coming together. Now what can I do? Let's see. V equals I times, can't do anything there. Still, but here, V equals I times R. So step number 2 was I know all current. Step number 3, well, I'm going to go back to black. Step number 3, I'm going to put right here, 3. V equals I times R. And I'm still at the bulb. V bulb equals I bulb times R bulb. So let's see, now I've got 5.53 equals what I just got, 0.79 times R bulb. I divide both sides, 5.53 divided by 0.79. I get a I get a resistance of 7 ohms. Perfect. Still can't do anything there. V equals I times R. Step number 4. V equals I times R. I'm looking for V, so this is just V equal 0.79 times 9. Can do that. 0.79 times 9. That gets me 7.11. 7.11 volts. I'm starting to leave some room here because I'm running out of boardroom. So let's see. Oh man, wait, now I could do lots of things here. I could do V equals I times R. I could do power equals I times V. So I'm going to do that step number 5. Just because I want to finish that one. Power equals I times V, and that is of R number 2. So I have 0.79 times 7.11. 0.79, 7.11. I get a power there of 5.616, so 5.62. And that's in watts. So I have 2 full things done, and I can even do more. Still with these simple equations. Voltage equals I times R. I'm kind of out of room there, so I'm going to move over here. I know that's backwards. So now I'm at step number 6. V equals I times R. Step number 6. I've got total. That's my total. And this is the weird word, equivalent. So I have 15 equals 0.79 times R. And I should know that this number is going to be bigger than everything. At the very end, I can check these things. So let's see. Divide 15 by 0.79. 15 divided by 0.79. 18.98, almost 19. 18.98 ohms. That's perfect. Now, oh my God, I can do this one too. I can do step number 7. I don't know why I just put a circle there. 7. Power equals I times V. And again, that's my total. So power total is 0.79, the total current, times the total voltage, 15. 0.79 times 15. That gets 11.85. And now I've got so much done. Everything is easy here. I don't even need any equations now. I can look at all of these rules again. So I'm only missing these top parts. My voltage rule is this one plus this one plus this one equals 15. V1 plus V2 plus V3. So that means 15 minus 7.11 minus 5.53 gets me the voltage that's left. 2.36 volts. And now I can check this 2 different ways. I can say V equals I times R. So I can solve this resistance twice, and I know I'm right if it works both times. If I do V equals I times R, 2.36, so number 8. Number 8. I don't have another clean whiteboard. So if I do, I'm going to put it up here. If I do V equals I times R, 2.36 equals 0.79 times R1, solving for R1. 2.36 divided by 0.79, 2.36 divided by 0.79. That comes out to 2.98. 2.98 ohms. So if I did everything right to check, this plus that should equal 18.98. That's my resistance rule. 2.98 plus 7 plus 9. 18.89, 18.9. Oh man, those are close. Remember, they may be a little bit off because of rounding, so that's good. Now the last one, I can do it again twice. Power equals I times V, or this plus that equals the total. I don't have that rule written down because that's not a special series rule. That's always. Power always adds up because power is like light bulb brightness. No matter what, if I have 2 lights near each other, they get brighter. So power always adds. So I'm going to say power equals I times V, 2.36 times 0.79. That is 1.86 watts. And now to check, 1.86 plus 4.37 plus 5.62 is 11.85, 11.85. Perfect. That's how we solve series circuits. Parallel circuits are very similar, but we'll get to that in a couple of days. If you have any questions, by all means, send an email, put a comment on YouTube, anything you'd like. That's it, and you'll see me next time.